Hi, I'm Mike Schodt, Automation Product Specialist at Winkle Electric, and today I'm going to demonstrate how to migrate an RSLogix 500 project into Studio 5000 using the RSLogix Project Migrator. Okay, getting started here with our project migration. We're going to be using a utility called the RSLogix Project Migrator. And it's a utility that's going to migrate older projects from RSLogix 5 or RSLogix 500 into the 5000 platform. And today we're going to be migrating an RSLogix 500 program into Studio 5000. Another thing I'm going to mention is that this utility is not going to be a 100% solution. There are certain instructions that don't have a direct conversion into the 5000 platform, so the utility will mark those rungs with a program conversion error, and at the end you'll have to go through and manually decide what to do with those, and we'll cover that here at the end of the video. Another thing is this reference manual we have on the screen here. This is available from rockwellautomation.com, and this guide will step you through the process. It'll show screenshots of the software, explain the different options, talk about errors that might happen and how to fix them, and then it goes into detail and explains what's actually happening behind the scenes on the conversion. So we're just going to minimize this for now. And here you'll see on the left I have my RSLogix 500 program open with just some basic logic in it, just to show how some of the instructions and data tables will migrate into the 5000 platform. Also you'll see I have a handful of I/O modules in it, and that'll be important to show how those modules get migrated. There's a series of options that you can choose to decide how you want to migrate those. On the right here I have a Windows Explorer window open. This is where this project file is located, and we're going to be generating some other files that go into here that will be used during the migration process. Okay, so we're going to open up the RSLogix Project Migrator, and this is a free utility that's installed with Studio 5000. One of the ways you can open it is from the Start menu through All Programs, Rockwell Software, RSLogix 5000 Tools, and here's your RSLogix Project Migrator. So this is the first screen on the migrator, but before we do anything there, if you're following word for word in the migration guide, what they recommend you do first is to clean up your existing project. And so there's kind of two steps we're going to do that. We're going to go to the Tools menu, and right away we'll just hit this Delete Unused Memory button. You hit Start, and it gives you kind of a report of what it did. You can see that file B3 was reduced by 1 element. The rest of them, there were no unused memory elements. So that's how that works. We're going to close that. The next step, go back to the Tools menu, Database, and we're going to go to Delete Unused Addresses. Click Yes. And there's nothing that could have been deleted here, so we're just going to click OK on that. All right, so now we're going to step into the RSLogix Project Migrator. Two options, one for a PLC 5, one for a SLC 500. We're going to choose the second option. And if you don't already have your RSLogix 500 window open, if you just click this button, it'll open it for you. Okay, and there's actually instructions right here on how to get started, so we're going to just follow those instructions first. So first thing we're going to do is we're going to save as a library file. Okay, and we're going to put it right in our Explorer window here so we can see where it's going. Save as library file and hit save. We're going to accept the default options that show up there. Okay, and there it gets dumped into our folder here. And you can see there's a handful of files, and then here's our SLC file. So the second instruction here is to export the symbol address descriptions. So we're going to just follow this word for word. Go to the Tools menu, Database, ASCII Export, and click on this CSV tab. Make sure this is checked here. We're going to export it as a CSV file, and we want to keep it the same name just for ease of moving through this. And so we'll hit OK. We're going to place it in the same directory. Status window says OK, and there's our file there. Okay, now we're into the RSLogix project migrator. We're going to browse for our library file. Okay, it's right out of there. I'm going to grab it. We hit open, and there's a checkbox. I had just mentioned that each file we're going to leave it as demo. If you, for some reason, needed to name your associated file a different name, you could deselect this and pick it here. But because everything's in the same directory, everything's got the same name, we can leave that checked, and it's just going to know to grab it. So hit next. So here we are in step 2, and this option will create alias tags for any existing symbols. And what I'm going to show you here in the original project, this timer here, you can see I created the symbol of T1. So if you leave this checked in your migrated project, there will be a tag named T1, and it's going to alias the associated timer for this. So if you're used to using those symbols, referencing those symbols, leave that checked, and then in your new project you can just go right on and keep referencing those tags. If you deselect that checkbox, what it'll do is it'll just take that symbol and put it into the description. So what you'll see is T1, this is a timer. This is a timer as the description. It just kind of puts them both together. So we're going to leave that checked. Hit migrate. This is kind of the first glitch you'll see if you're using a Slick 500. The migration guide kind of talks about this, but it doesn't really explain how to correct it. Anytime you get an error during this step, it's going to give you the window here and give you the opportunity to correct it. It tells you the syntax error is at line 1, but we don't know what it is. There is a knowledge base article on this, but I'll just show you right now. This revision letter and this comma is what it doesn't like, so we're just going to highlight them and delete it, and go ahead and hit save and retry, and it'll move on through. So now we'll hit next, and now we're going to pick our output file, where it goes, and our controller type and our version. So for controller type, I'm just going to pick a 1769 L30ER. And one other thing to note, your version will only go up to 27 and down to 21. So if you need to go above 27, you have to select 27 here and then either change it manually in your project, or you can actually do it during the import process. And I'll show you how to do both. Now we're on step 5, and we're going to be talking about what to do with our I/O. You have a bunch of different options here. The default option here is to keep existing I/O in a separate rack. So there's two things in here. There's keep existing and separate rack. This is a situation where you might want to put in a 1747 AENTR card in place of your controller, and this will allow that and just migrate that option into your project file. Now, if you didn't want to keep the existing I/O in a separate rack, you do have the option to replace all the I/O with newer models. So we can select that, and then you can see we get more options come up down below. So it will show you the hardware that's already in there. If you remember, here's the hardware configuration, the I/O configuration. So it'll show each module and then allow you to drop down and select the 1769 replacement, because we picked the controller type as a 1769 compact logic, so we're going to get the 1769 compact I/O. So we can go ahead and select those, And now you'll see there's some other options that show up here. One of them being create placeholder tags. So I'm going to do that for these last two modules. And what that'll do, that won't actually put the I/O module in the configuration. It'll leave these out, but it'll create placeholder tags for those tags that were used in our original project. So that way, if you want to add the hardware in later, you can just quickly map those tags to your hardware tags. And then the last thing down here below is this checkbox. You can put the replacement I/O into a remote rack, or if you deselect this, it'll put it right onto the back plane of your controller. So I'm going to leave that deselected. I want this I/O modules to go right on the back plane. Okay, so now we migrated through, and if you saw, here's it migrates it into a RSLogix 5000 import file, which is a .l5k file. So now at this point, I'm just going to hit exit. We're pretty much done, and we're going to open up Studio 5000. And we're going to import our import file here. We're going to grab it. So now we're here to our dialog to save the imported project, and you'll see in the corner this is an opportunity where you can change your revision up to current, which at the time of this video is 32. I'm going to leave it at 27, and we're going to go ahead and save it into our desktop, and I'm just going to call it demo. And here's where I would click import, and Studio 5000 would go through the import process and create the project. For the sake of the video, I already have one open, and this is how our current project will import. And just to look over the configuration first, you'll see that slot 4 and 5 is not there with our I/O configuration, and that was because we decided to create placeholder tags instead of adding actual replacement hardware. So it did not put a module into those slots, and we'll see in the controller tags that there are actual placeholder tags. So let's open up the controller tags, and here we're going to see a little bit about how some of our data types transferred in. And what I'll do is do a direct side-by-side comparison, and first we'll take a look at our binary file, how that transferred in. So you see in our RSLogix 500 project, we just have our data table, our data files here, and this is the equivalent in our Studio 5000 project. What it did was it just took these 16-bit integer register values, and it actually put them into double integers and made an array. So here you have B3:0. It's just the 0 element of this B3 array, and it's going to contain the same tags. Now, because it's a 32-bit data type, you'll see bits number 16 through 31 just won't be used. So bits 0 through 15 over here on our 500 project will become bit 0 through 15 in this first part of this array here. And you can see there's 3 total elements to equal the 3 total registers in this data file. The other data tables will get migrated in the same way. Down here you'll see our timer. Our timer table, there's two timers in that. This created an array of 2 timers as well. One other thing you'll notice, we checked a box to create alias tags for the symbols, and if you remember, T1 was a symbol for the timer that was in T40. So this timer actually is being aliased by this tag here. And if I expand our window, you'll see in our alias for column, T1 is its own tag now, which is an alias for T4 element 0. Okay, one other thing you'll notice in our I/O hardware tags, the description gets changed, and there's a description here that's just generated by the migration tool. So we did have descriptions in some of our other I/O tags. They were not lost. They're actually placed into this tag here, and you'll see this is where those descriptions went. So this is kind of one of the first steps in manually making your project correct. So what we'll do just real quick, just a simple copy, and we'll paste it in there. And then do the same for the other one. Okay. Now we'll take a look at our placeholder tags here, and you'll see it's labeled in a descriptive manner. You know, slot 4, slot 5. It even has the I/O module catalog number in there. So these are the placeholder tags that were created rather than actual hardware modules in the configuration. So one thing you can do is if you add in these hardware modules later, an easy way to get it to map into that would be to just do a map these tags right into your hardware tags. Okay, closing the controller tags here. We're going to take a look at our task structure and what the conversion tool does. It sets up the tasks and programs and routines in the closest way to mimic the SLC 500 controller, the way that it scans the logic. So the way that it does it, it creates a continuous task, a main task here, and in the main routine we have an event, a trigger event task, and this is going to call the to main ladder. And if we look at it here, this is just going to have all of our jump to subroutines for all of our other routines. All right, so digging in here a little more, we have some of the logic that was converted. And remember at the beginning I said that any instruction that doesn't fully convert will get marked by a program conversion error instruction. So this is what that instruction looks like here. Each instruction has a code as for why it was placed in there, and then a text up here gets put into the rung description that says exactly why it was put in there. So in this particular case, we had used a timer that had a 0.01 second time base, and of course in 5,000 projects everything has a 0.001 second time base. So we used a greater than or equal to instruction that references the accumulator value in that timer. So it's pretty much saying that this needs looked at. Your time base changed, so this instruction may not be correct anymore. And the way we would make this correct is just to simply add a 0 to that 500. And now we have an equivalent instruction that works the same. So we would just, now we fix that, we delete that PCE instruction, and we can delete that wrong comment as well. So that's an example of some of the manual steps you'll have to take when you have your converted project. Now we'll see one other instruction that doesn't quite convert properly is a message instruction. And they're kind of set up a little bit different in the 5,000 projects. So here again we have our PCE instruction, a different code here. pretty much just saying you need to check all of the settings in your message instruction. And if we open it up, one of the things you'll see missing, there's no path in here. They're set up a little differently, so you'll just have to go through the settings and make sure it's correct, make sure it's pointing in the right place, and all that. And here we just have some generic ladder logic. Here you'll see some of those descriptions that got put in automatically that you can take out. This is another instruction that just is not supported in 5000, so you'll have to take a look at that, figure out what you want to do with that. You may not even need that instruction anymore, but there, another area where you might have to make a decision as to what to do. Okay. Now closing up our ladder logic, one last thing. I talked about changing the revision, and I'm going to actually just do it here. There was that other spot during the import process you could have done it, but here's the last place you can do it. And I'm just going to go ahead and hit OK and save the changes. I hope you enjoyed learning how to migrate an RSLogix 500 project into Studio 5000. The software, however, is only half the job. Now it's time to replace that old hardware. So if you're planning your own migration or have any questions, please reach out to us at Winkle Electric or go to winkle.com. Once again, I'm Mike Schodt, Automation Product Specialist at Winkle Electric Company.